All right, let's go ahead and talk about the ideal gas law where we can take a given situation, a given set of conditions where we know 3 of 4 possible variables, and then we can use those 3 variables to calculate the 4th one. Now this is the equation right here. Again, this is the ideal gas law equation, and one way in which it's called PIV-NERT, because if you sound it out, it kind of sounds like that. And again, we can use this equation to calculate a variable if we know the other variables. So let's go ahead and go through what each one stands for. So we have P is pressure, V is volume, N is moles, T is temperature, and then we have R, which R is a gas constant. Now, because it's a constant, we will always have R, so we will always have this particular value right here. And so again, if we're given 3 variables, for example, if we're given P, V, and N, we can then calculate T. If we're given T, N, and P, we can calculate V. And so again, if we are given 3 of the 4 variables, we can calculate the 4th one. Now let's go ahead and talk about R. This here is a table that shows the R values. Now there's 3 R values that we're going to deal with in this class, but notice how notice what is different between each R value. Each R value will be in moles. So if we're the units for N is moles. The units for T is Kelvin. This is very important. The units for V is liters. So if you're given milliliters, you have to convert it to liters. And just a reminder, 1 liter is equal to 1,000 milliliters. But what's different about each R value is the unit of pressure that we're dealing with. And so really, when you're working through these problems and you're trying to figure out which R to choose, well, whatever units of pressure your pressure, whatever units your pressure are in is going to determine which R value you use. Now, just a quick reminder, temperature has to be in Kelvin. So if you're given Celsius, you have to convert to Kelvin. N has to be in moles. So if you're given grams, you have to convert to moles. Volume has to be in liters. Now, for the combined gas law, which is P1V1 over N1T1 equals P2V2 over N2T2, that one can be liters or milliliters. But in this particular problem, it has to be liters. And then pressure can be atmosphere, millimeters of mercury, or kilopascals. So these are the units of measurement that we will be dealing with in terms of pressure. So pressure is the only one that can have different units there. All right, so let's go ahead and do this practice problem here. So this is saying, first off, this is asking for pressure, and it's asking for pressures in atmospheres. And so it's saying, what is the pressure in atmosphere exerted by this many moles? Okay, so here's N. In that many moles, in 0.5 mole sample of nitrogen gas in a 10-liter container. So here's V at 298 Kelvin, which here's T. So notice how we're given N, V, and T. We will always have R, so then we can just plug in these variables into this equation here, and we can calculate P. And so we don't know what P is, but we do know V is 10.0. We know N is 0.500. Now R, that's a constant, so which R value are we going to use? So if we take a look here, what R value are we going to use between those 3? And again, it comes down to, well, what unit of pressure are we dealing with? The problem is specifically wanting us to calculate it in terms of atmospheres. And so the R for atmosphere is 0.0821. And then we have T. The last one is T here. And so once we plug this in, the only thing we need to do now is we need to just solve for P. And how you get P alone by itself is you divide each side by 10. And when you divide each side by 10, this cancels out to where we are left with this situation here. And we just plug this into our calculator. And what we end up with is P is equal to 1.22 atmospheres of pressure. Notice how it has 3 sig figs, because all of the other values are 3 sig figs. And that's our answer there. All right, let's go ahead and move on to the next problem here. The next problem, now it's asking for the volume, okay? So we're looking for the volume in this situation. Now, this here is grams. Now, this equation here doesn't have grams. However, what can we do to the grams? We can take the 8.00 grams of oxygen gas, and we can convert them to moles. And we know that 1 mole of oxygen gas, and don't forget that oxygen is a Hofbrinkel, is going to be 32 grams per mole. Because if you look at the molar mass on the periodic table, it's about 16. 16 times 2 is 32. And then when you type this in your calculator, you end up getting 0.250 moles of O2. So there we go. This is our N. We also, if you take a look here, this is our T. However, it's in Celsius. It's in Celsius. So we need to take our Celsius and convert it to Kelvin by adding 273. What I'll say is this is one of the bigger mistakes that people make on the exam is they don't convert the Celsius to Kelvin. All of these equations need to be in Kelvin. And the messed up part is that one of the wrong answers on the exam is going to be the answer you would get if you don't convert it to Kelvin. And so we have that for temperature there, and then we have our pressure right here. So let's go ahead and plug this stuff in here. So we have 740.24 for our pressure. Okay, so we just plugged in our pressure. We're looking for the volume. It's asking for that. We just calculated the moles. R, well, that's going to be the gas constant, which, let's go ahead and take a look here. Which of the gas constants are we going to use? Well, again, it's dependent on whatever unit the pressure is in. So what units are the pressure in? Well, here's pressure. Notice how it's in millimeters of mercury, which is this one right here. So we're going to use the 62.4 for this one. Because again, the pressure is in millimeters of mercury. And then we plug in the temperature, which is 20 degrees Celsius plus 273, which is going to be 293. And there it is. And so all we do is solve for V by dividing both sides by this. When you do that, that cancels. And we're left with this setup right here. And all we need to do is plug that in the calculator. And what you end up getting is V is equal to 6.17 liters. There it is. So what I want to say is these problems are actually really easy because all you have to do is take your PV equals nRT and plug in the numbers into that. Now what I will say is challenging is determining that this is the type of problem that you have to use. So let's go ahead and talk about that for some more. Let's take a look at these problems right here. Again, what we're talking about today is we're talking about PV equals nRT. If you remember last class period, we learned that P1V1 over N1T1 equals P2V2 over N2T2. This is the combined gas law. This is the ideal gas law. Now, how do we know when to use one versus the other? The way you know that is this one you use if there is a change. If there is a change in condition, that's when you use the combined gas law. So let's go ahead and read this problem here. It says that a sample of oxygen gas has a volume of 150 milliliters and a pressure of 0.94. Then it's asking what will the volume of gas be at a pressure of 0.987 atmospheres. So notice how there's a change in pressure. if there is a change, that's when you use this particular equation. However, look at this problem here. It's saying what mass of chlorine gas in grams is contained in a 10-liter tank at 27 degrees Celsius at 3.5 atmospheres of pressure. Notice how in this situation there is not a change. We don't have an initial volume and a final volume. We don't have an initial pressure or a final pressure, and so on. And so in this situation there is no change, so that's when we use PV equals nRT. Now this is not asking for anything that's within this equation here. So we have pressure, volume, moles, and temperature. This isn't asking for any of those. This is asking for grams. So how do we find grams? Well, if we find the moles, we can then convert the moles to the grams. And so for this particular problem, just recognize that it's asking for grams, which means you have to solve for moles and then convert the moles to grams. So let's go ahead and do that. So we've got our pressure, which is 3.50 atmospheres. We've got our volume, which is 10.0 liters, equals to, we are looking for the moles, so we don't know what the moles are. If we look at the chart here, we're dealing with atmospheres of pressure, so that means we're using this R value, 0.0821. And I'm just going to go ahead and say right now, a lot of people forget this 0 when they're calculating things, so it's 0.0821. So make sure you include that 0 when you're typing in your calculator. All right, and then we have Celsius. Again, if we're given Celsius, we have to change it to Kelvin by adding 273. And this is going to give us 300. And so now we have this set up here, and all we need to do is solve for N. And the way you do that is by dividing both sides by this. So you divide both sides by that. What happens is these cancel out, which means that we have N by itself, and essentially N is going to be equal to this particular setup. And all you need to do is type that in the calculator, and you end up with N is equal to 1.42 moles of chlorine gas. Now again, the problem isn't asking for moles of chlorine gas. And I'm going to let you know, if this were a multiple choice question, one of the incorrect answer choices would be this right here. So you've got to really pay attention to what it's asking for. It's asking for grams. But again, if we have moles, we can just simply convert from moles to grams like we've been doing this entire year since Unit 2. Oops, not what I wanted. There we go. And we know 1 mole is going to be 70.9 grams of chlorine gas, and that's because 1 atom of chlorine is 35.45, but we don't have 1, we have 2 because it's a Hofbrinkel. And then when you type that in your calculator, you end up with grams, you end up with the answer being 101 grams of chlorine gas. And that is our answer there. So again, these problems are, they are straightforward, but the problem is identifying which type of problem we're dealing with. If there is a change, for example, this one, there's a change. We have volume, temperature, and then we have a different temperature. There's a change in temperature. So that is going to be this one right here. And this one, we don't have any change. We're just given 3 of the 4 variables. If you're ever given 3 of the 4 variables, you can always use PV equals nRT. And so that's just kind of what you got to look for. So that is the ideal gas law. Again, it's making sure that you're able to identify what type of problem you're dealing with. But once you identify, it's really easy. You just plug in the different variables, and then you solve for the one that is the unknown. And that's it. You guys have a great day.